Namaste and welcome back to our channel, where we dive deep into the fascinating world of history, scientific theories, and discoveries. Today, we embark on a journey to unravel the scientific wonders of ancient and medieval India. Join me as we explore the profound knowledge and innovative discoveries that shaped the scientific landscape of the Indian subcontinent. Let's get started. Albert Einstein once said, "We owe a lot to the ancient Indians, teaching us how to count. Without which most modern scientific discoveries would have been impossible." India, a land known for its rich cultural heritage, was also a cradle of scientific advancements. Ancient Indian scholars made remarkable contributions to various fields of science, astronomy, mathematics, medicine, and more. Let's begin with one of the most famous ancient Indian scientific texts. The Vedas, the oldest scriptures of Hinduism, contain profound insights into the natural world. They explore concepts like cosmology, astronomy, and the nature of matter. One of the notable scientists of the ancient India was Kanad, who is said to have devised the atomic theory centuries before John Dalton was born. He speculated the existence of Anu, or a small indestructible particle, much like an atom. He also stated that Anu can have two states, absolute rest, and a state of motion. He further held that atoms of same substance combined with each other in a specific and synchronized manner to produce dvyanuka, or diatomic molecules, and trianuka, or triatomic molecules. Mathematicians of ancient India often applied their mathematical knowledge to make accurate astronomical predictions. The most significant among them was Aryabhata, whose book, Aryabhatiya, represented the pinnacle of astronomical knowledge at the time. Aryabhata, in his treatise, proposed a heliocentric model of the solar system, centuries before Copernicus. He correctly propounded that the Earth is round, rotates on its own axis, and revolves around the Sun, hence the heliocentric theory. He also made predictions about the solar and lunar eclipses, duration of the day, as well as the distance between the Earth and the Moon. Additionally, the Arthashastra, authored by Chanakya, delves into topics such as governance, economics, and military strategy. A pioneering steel alloy matrix was also developed in India. Wood steel is a crucible steel characterized by a pattern of bands, that was known in the ancient world by many different names such as Akku, Hindwani, and Sarak iron. This steel was used to make the famed Damascus pattern swords, that could cleave a free-falling silk scarf or a block of wood with ease. Produced by the Chera dynasty, the finest steel of the ancient world, was made by heating black magnetite or in the presence of carbon in a sealed clay crucible kept inside a charcoal furnace. In the field of medicine, ancient India witnessed significant advancements. The Sushruta Samhita by Sushruta and the Charaka Samhita by Charaka are two prominent texts that laid the foundation for modern surgical practices and Ayurveda, the traditional Indian system of medicine. Written by Sushruta in 6th century BC, Sushruta Samhita is considered to be one of the most comprehensive textbooks on ancient surgery. The text mentions various illnesses, plants, preparations and cures along with complex techniques of plastic surgery. The Sushruta Samhita's most well-known contribution to plastic surgery is the reconstruction of the nose, known also as rhinoplasty. The first cataract surgery is said to have been performed by the ancient Indian physician Sushruta, way back in 6th century BCE. To remove the cataract from the eyes, he used a curved needle, Jabamukhi Salaka, to loosen the lens and push the cataract out of the field of vision. The eye would then be bandaged for a few days till it healed completely. Sushruta's surgical works were later translated to Arabic language, and through the Arabs, his works were introduced to the West. Long before the birth of Hippocrates, Charaka authored a foundational text, Charaka Samhita, on the ancient science of Ayurveda. Referred to as the father of Indian medicine, Charaka was the first physician to present the concept of digestion, metabolism, and immunity in his book. Charaka's ancient manual on preventive medicine remained a standard work on the subject for 2 millennia, and was translated into many foreign languages, including Arabic and Latin. Moving on to astronomy and mathematics, ancient Indian scholars made remarkable strides. The works of Bhaskara, notably the Bijagyanita and Lilavati, showcased advanced algebraic techniques and solved complex equations. Madhava of Sangamagrama's contributions to calculus and infinite series are often regarded as precursors to Newton and Leibniz. Little needs to be said about the mathematical digit zero, one of the most important inventions of all time. Mathematician Aryabhata was the first person to create a symbol for zero, and it was through his efforts that mathematical operations like addition and subtraction started using the digit zero. The concept of zero and its integration into the place value system also enabled one to write numbers, no matter how large, by using only 10 symbols. India gave the ingenious method of expressing all numbers by means of 10 symbols, the decimal system. In this system, each symbol received a value of position as well as an absolute value. Due to the simplicity of the decimal notation, which facilitated calculation, this system made the uses of arithmetic, in practical inventions much faster and easier. Indians, as early as 500 BCE, had devised a system of different symbols for every number from 1 to 9. This notation system was adopted by the Arabs who called it the Hind numerals. Centuries later, this notation system was adopted by the Western world who called them the Arabic numerals, as it reached them through the Arab traders. The Fibonacci numbers and their sequence first appear in Indian mathematics as Matramar, mentioned by Pingla in connection with the Sanskrit tradition of prosody. Later on, the methods for the formation of these numbers were given by mathematicians Virahanka, Gopala, and Hemachandra, much before the Italian mathematician Fibonacci introduced the fascinating sequence to Western European mathematics. Binary numbers is the basic language in which computer programs are written. Binary basically refers to a set of two numbers, 1 and 0, the combinations of which are called bits and bytes. The binary number system was first described by the Vedic scholar Pingla, in his book Chandasastra, which is the earliest known Sanskrit treatise on prosody, which is the study of poetic meters and verse. The Chakravala method is a cyclic algorithm to solve indeterminate quadratic equations, including the Pell's equation. This method for obtaining integer solutions was developed by Brahmagupta, one of the well-known mathematicians of the 7th century CE. Another mathematician, Jayadeva, later generalized this method for a wider range of equations, which was further refined by Bhaskara II in his Bijagyanita treatise. Excavations at the various Indus Valley sites have yielded rulers or linear measures made from ivory and shell. Marked out in minute subdivisions with amazing accuracy, these measures were traditionally used in the ancient architecture of South India. Ancient bricks found at the excavation sites of Indus Valley civilization have dimensions that correspond to the units on these rulers. To further their astronomical pursuits, ancient Indian scientists constructed grand observatories. The Jantar-Mantar observatories, such as the one in Jaipur, were marvels of architecture and precision instruments that allowed for accurate celestial observations and measurements. Metallurgy and chemistry also flourished in ancient India. The Iron Pillar of Delhi, dating back to the 4th century CE, stands as a testament to the advanced knowledge of ironworking. Furthermore, the ancient treatise Rasratnakara describes various chemical processes and compounds. India was the first to smelt zinc by the distillation process, an advanced technique derived from a long experience of ancient alchemy. The ancient Persians had also attempted to reduce zinc oxide in an open furnace, but had failed. Zawar in the Tiri Valley of Rajasthan is the world's first known ancient zinc smelting site. The distillation technique of zinc production goes back to the 12th century AD, and is an important contribution of India to the world of science. Ancient India was known for its remarkable engineering prowess. The elaborate water management systems, such as the step wells like Rani Ki Vav, showcased the expertise in hydraulic engineering. Additionally, the grand architectural wonders like the temples of Khajuraho, and the rock-cut caves of Ajanta and Ellora astound us even today. As we conclude our exploration of the scientific theories and discoveries of ancient and medieval India, we realize the immense knowledge and innovation that flourished during those times. We hope you enjoyed this journey through the scientific wonders of ancient India. If you did, don't forget to hit that like button, share the video, and subscribe to our channel for more captivating content. Until next time, stay curious.